I'm going to be pushing you to be doing, we're going to spend multiple days on this, okay? Basically. So tomorrow is an asynchronous day, and I want to kind of treat that as an asynchronous day. I'm going to give you new problems to be able to solve, um, to be able to do those types of problems. So um, tomorrow's problems will be an extension of today's type of problems. On Monday, I need to show you the graphing calculator one more time for a new type of problem, and we'll get to there as well. So the normal model can be used to approximate percentages above, below, or between values if the distribution is approximately normal. All right, which means, of course, to be approximately more normal means that the distribution is roughly unimodal and roughly, or sorry, unimodal, it's better to say unimodal first, unimodal and roughly symmetrical. So if the distribution isn't unimodal and symmetrical, okay, if it is not roughly unimodal and symmetrical, unimodal, roughly symmetrical, then the normal model doesn't apply. All right, so if you try to use the normal model to find percentages for something that is not unimodal and symmetric, your answers are not gonna be reflective or close to the actual answers. All right, it's an approximation for the most part for most distributions. The biggest mistake is we will find is I'm going to ask you questions about is something unusual, for example, and when you find something's unusual, you just find the z-score and you want to analyze the z-score. And the reason is what students make a mistake is I never tell you anything about what the distribution looks like, and therefore you go and you try to use the normal model and you try to use the work that we're going to do today or the empirical rule, and you get a percentage. You get a value like, oh, 99.7%. And I have to go, no. You did something very bad because you should not have used that. Nothing in this problem states that you should use something it's not roughly unimodal or symmetric. It's not approximately normal. It didn't say that it was normal, the distribution. Therefore, you can't use the normal model. So that's first and foremost, and I believe I put a problem on that happens in tonight's homework. But the most important thing was we're going to talk about utilizing the graphing calculator to find area, which is percentages, which is really just percentages, okay? This is what we really want to focus on today. Now, we could use the normal model to get our answers, but we want to do it this way as well. Let's look at the example we did yesterday. SAT math scores are normally distributed with a mean of 500 points and standard deviation of 100 points. Find the percent of students, or approximate, I might say, approximate the percent of students who score between 400 and 600 points. Okay. So if you score on the math SAT and your score is below a 500, that means you scored below the mean, below the average. And these are nationwide scores, okay? So the national average of the SAT math is 500 points. The national average for the SAT verbal is 500 points. So if you score below 500, that means you're below the mean. You have a negative z-score. If you're below 400, that means you're below a standard deviation, all right? And then 2 standard deviations if you're at 300 and so forth. Now, we're going to solve this problem. And everything that we do to solve this problem works exactly the same to do this problem initially, okay? So what do I do in solving this problem? How do I get my, how do I show my work? How do I get full credit? Nothing's different from yesterday so far. I make a sketch, yes. Graph, sketch the graph. So whoop, whoop. Okay, and I'm gonna label, on my sketch, I'm gonna label the what?
The mean 500.
The mean 500. And I'm also gonna do what? At 100. Well, yeah, I'm going to show the two values right here. 400, 600. Okay, what do I do now? This is what you should have been doing last night on last night's homework. You all did your homework, right? So that you should all have done this, right? So, what do I do now?
Add the mean and the standard deviation times 2.
No, we're not talking about anything about outliers. What do we do with their sketch? What is my sketch missing? Shade. Yeah, thank you, Darius. Shade. I want to find between. I want to find between. So I want to find that area. Okay. Next, what do I find? Go through that checklist. Look at yesterday's notes. Sorry, my chat.
You calculate z-scores?
There we go. Yeah, and yeah. Sorry, Anna, I wasn't even. You calculate the z-scores. So z equals. How do I calculate? Let's calculate the z-score.
Well, I don't know that the same as you.
What? No.
That's a see a score of the question. I don't remember, bro. I don't know how this. What is his name? Doesn't matter. It's 16 negative 14. 600 negative 400.
No.
Over
no,
100.
No. 600 minus.
Oh, 500.
500, the mean.
Over 100.
Which equals.
1. That's 100, so it's not the same.
So sorry, that's not 600. Sorry, it's not 600 here. It's, you should be able to look just right on your answer sheet from yesterday. We literally did this problem yesterday. I'm almost virtually copying it down right now.
400.
400, yes. Which gives me.
So it's negative 1.
Yes. And then we have to find this other z-score, which is
600 negative 500
minus,
over 100
minus 500 or 100.
Equal 1. Okay. It's because I had 2 delivery. No, 2, yeah. So it's 2 CD.
I don't know what they said.
No, CD is what's that deviation? What's that mean? Standard
S.
deviation.
Oh, yeah, but that's so. Yeah, I don't know. See, CD. There's no CD. I think you're referring to standard deviation. That's why we want to use the word, but it's an S. Um, but the whole premise here is that we first need to show this. This is the most important thing. Now, I've stated also that this is a normal model, and I've also stated the mean and standard deviation. So that's very important. I've stated the mean and standard deviation 500, 100 in my formula. Now, you could have also have done normal 500, 100, but it's not really a requirement because you technically say that by doing this, okay? And the next thing we do is we find our answer and we include context, okay? So next thing is answer and context. Now, based on what we did yesterday, our answer is what? What is our answer? Again, we did this yesterday. You have the answer in front of you. He's about, yeah, so 68%. So we would say approximately 68%. So we already know that the answer is approximately 68%, right? We already know that as well. But that's using that model, and that means you're going to use that one. So there's a couple of things. Now, in this problem, the z-scores were exactly -1 and 1. And in your homework, the z-scores were exactly -1, or it were -3, -2, -1, 0, 1, 2, or 3. It lands exactly on those. And in tonight's homework, that's going to still be the case. In tomorrow's homework, I'm going to give you other z-scores. So we're going to have decimal z-scores. You're going to have z equals like 1.5. So we will have to use the calculator. So I want to show you how to get the 68% using a calculator. So to calculate on the calculator, we got this one by using the empirical rule because it's perfect. But to calculate on the calculator, we use the function normal CDF. This stands for the normal cumulative distribution function. That's what it stands for. But we just say normal CDF. The word cumulative means below. So it means it's the sum. It's the sum below, or it's the sum. Yeah, it's a sum. But we need to be able to tell this calculator what are we trying to do. So let's take a look at the normal cumulative function and how to find it. Now, typically to find normal CDF on a graphing calculator, well, normal CDF takes in, there's two ways to do normal CDF. Normal CDF takes in the z-scores, the left z-score, then the right z-score, and we can do it like this. This is how I traditionally want you to use it. You can also use normal CDF using the x values and then stating the mean and the standard deviation. Now, I traditionally always use the z-scores because we found the z-scores and in today's lesson, that's going to help us make that connection with what we did yesterday. Okay, so I'm going to actually be utilizing this now. Technically, what's being done here is it's doing normal CDF, z left, z right, and without us knowing it, it's plugging in a mean of 0 and it's plugging in a standard deviation of 1. So without us even knowing, if we don't, it's when we put in the values and we don't put anything after those first two numbers, it's saying, oh, those numbers must be the z-scores because we're going to automatically use a mean of 0 and a standard deviation of 1 if you don't tell me what the mean and standard deviation are. I am okay with you doing either way as long as you have everything that's here in green. As long as everything here in green is drawn, I don't really care how you get the answer after this. You've shaded, you've shown your normal model, you've calculated the z-scores. Now let's find the answer. Okay. You can get to the normal CDF. You can get to here on your graphing on a TI, not an IT. Graphing calculator, and most of them as well. You get to here by hitting second, and then the vars button, which it has a little, it says distribution on top of it, and then selecting the second option. Typically, it's a second option, and it's normal CDF parentheses. Now there will also be a normal PDF. So you might, if you're using one of the other apps, you're probably going to have to upgrade. This is to add as well. So you will now need to have the features if you're using an online calculator. Typically, the free versions of the calculator all do not let you have access to the normal CDF. All right, they do not give you access to those. So you have two options. You need to, now I believe, you can use Desmos. I'm going to show you Desmos, which is the other free one, but it just doesn't, it's not as great as the other calculator apps and having that physical calculator or looking at it. So you have a couple of options. You can use Desmos. You can use, you can upgrade on one of those calculator apps. Because most everything I'm going to do is I'm going to run it like it's a TI graphing calculator because that's our home, a TI graphing calculator. But you can do anything else. You can even do it with a Casio. Ugh. It's really ugly to do it. But you can do it there. As long as you can get to the normal CDF, the normal cumulative distribution function. Not normal PDF, right? Okay, so not normal PDF. We will never use normal PDF. No, 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 no. Do not use it. That's a big no-no. No. CDF. So in my answer here, I want to type in normal CDF, and let's use the z-scores. So what are my two z-scores here that I'm going to use? What am I trying to find the area between for z-scores?
-1 and 1.
So I would just type -1 and 1. And this will give me the answer, okay? This tells me to find what we have to know, that we have to interpret this. This says the area under the normal model between z equals -1 and z equals 1. So that's what this says to do. It's telling me to do this. It's telling me to find this picture, this area right there. All right. Now on the AP exam, they do not give you any credit for writing normal CDF, but I want you to write normal CDF so that you can see what you typed in. All right, we're going to do it this way first, using the z-scores that we found. All right. Go to the calculator. Everybody, hopefully you got the calculator there. Okay. Okay. So we have the calculator. I'm gonna hit. See in this calculator, it's different as well. You see the distribution, the blue little distribution is actually above solve for this calculator that I'm using. But I want to get to the distributions because it's a normal distribution. So I'm gonna hit this calculator. I'm gonna hit Shift and then solve because that's gonna give me that blue one up there. And then the second option is normal CDF. Now, if your calculator is updated or you're using one of these, notice that in the previous one I said -1, 1. All right. In these ones, in this calculator, you're going to, and this is also why when you're using these calculators, it's easier to do it the second method, which I'm going to show you. We're going to put the lower. So what is my lower boundary for my area? What did I say what my lower boundary was?
400?
No, the z-score.
Oh, -1.
-1. And like I said, I'm just going to do it this one time to kind of show you why it's done this way. And then if you're using this calculator, you'll do it the other way that I'm going to show you just in a bit. And then my upper one was z equals 1. And I should be using a mean of 0 and a standard deviation 1 by default. Now the mean of 0, now this calculator, that's why I say you have to know how your calculator is going to be requesting this input. You're going to use this a lot in this course, a lot. So does your calculator look like this, or does your calculator look like in terms of the other one when it's in the other mode? In other words, does it look like this? Now, once again, I told you you can actually delete. You know, if your calculator does not, you could have actually typed it in like this, and it'll also work out. All right, because and you see how it says bracket mean standard deviation, it assumes zeros, and then I hit enter, and I get 0.683, right? Well, wait, 683. What 0.683? This gives me 0.683, which is also known as like 68.3%, which is about 68%. So we
You don't have to do that, even though it's always going to be like kind of 68%.
Well, that's the reason. So one of the nice things, and that's very efficient, is if it lands exactly between one standard deviation, you should be automatically going, oh, that's 68%. I don't even have to use the calculator. We'll accept it. If it's between two standard deviations, 95%. I don't need to do any calculations. I know that from the empirical rule. But spoiler alert, tomorrow it's not going to be between one standard deviations. And the next problem I'm going to give you is going to be a little bit tougher. Using the mean and standard deviation. So if I'm going to use the mean and standard deviation, I could have done the same thing by doing normal CDF, and you just ignore the z-scores. Okay, in this case, yes, you had to find the z-scores. Finding the z-scores is a requirement on the AP exam. If you do not find the z-scores, you do not get credit. So you found the z-scores, but after you found the z-scores, you can ignore it. You're just going to use that 400, 500 piece, okay? And you're going to use the mean and standard deviation in your formula. So you're going to use normal CDF, and we can do the same thing, saying that this area that's below it is 400. I want to find between 400 and 600, where the mean is 500 and the standard deviation is 600. Is 100. And technically, you wouldn't write those. You would just write it like that. Okay. So you can actually type that like that into the calculator. Okay. So, and this is typically how I want most of you to do it, because the way these online calculators work is like this. So second distribution, normal CDF. I want to find the area between 400 and 600. The mean of my distribution is 500, and the standard deviation of my distribution is 100. You just, that's the same thing that we did. It'll do the same work. I paste it. I could have typed it into my calculator like this: 400, 600, 400, comma 600, comma 500, comma 100. You can see why having these updated calculators, you're like, well, wait, what number do I put first? What number goes second? How many numbers am I supposed to use? If you have these calculators, especially online like this, you can get the answer, and I hit enter, and it gives me the same
Wait,
thing.
so to get normal CDF for like a regular like a TI calculator, what do you do?
Just like the notes, second vars. It'll the DIST. It's you want to get to the you want to get to the distributions. You want to find the DISTR button, and for the regular graphing calculators, the TI graphing calculator, that is above bars, and to get to it you have to hit the second button or the shift button. This is an option. You can go to functions. You can pull out the keyboard, functions, and DIST stands for distribution. So there's the distributions right there, and you see one of them says the normal distribution, normal DIST, and it says that we want to find the normal cumulative distribution, and we want to find the way this one is requesting it, this one says you put in the mean and standard deviations right in here. So we would put the 500, comma 100 into here. That tells me the mean and standard deviation, and then we want it from 400 to 500 to 600. Sorry. So the way the Desmos will do it for you, and Desmos is completely free, but you have to understand what it's doing. So the way Desmos works, it says, hey, tell me, and it has some advantages to it. This Desmos calculator has some advantages to you, as I'll show you in the next problem. This one says, first, in parentheses, tell me what the mean and standard deviation are. That's what it's asking you. Okay, let me type in the mean and standard deviation. And then, now, if you don't put anything in there, it uses a mean and standard deviation of 0. So all we have to technically put under minimum are the z-scores. So we would just put -1 to 1, and I can just type in the z-scores like that. So the Desmos does make it say. I mean, it's just a different way of typing it in. And the nice thing about Desmos is it actually, look, it showed you the sketch. It showed you the sketch that we drew. And technically, when I drew that other one, and I said 500, comma 100, and I had from 400 to 500, so 600. Yeah, the sketch doesn't really do a good job on terms of that one, it turns out. But it did do it. So you can do it either way with Desmos, with the graphing calculator app, with your calculator. It all does it the same. It does it. That's the main thing. You need to be able to find the area. How are you going to choose to find the area? Now, like Mariana was saying, couldn't you just use the 68% because you know it is? And the answer is yes. All right, so about 68% of students score between 400 and 600 on the math SAT. Now, let's talk about my answer. Let's talk about the solution that I wrote. What are some important features that I did in my solution? What does this solution include? So context. It included the who, which was students. It included the what, which were SAT math scores. It also included, which are in, I guess 400, because it included units. Because, SAT math scores, I mean, it's points. I could have included points here, but this 400 is kind of like its own unit. So it included context. What else does my answer include? Includes the answer, which was 68%. And there's one last thing that this answer includes that's very important that can be overlooked. Well, that's just regurgitating the problem. That's still context. And we call this it's non-definitive. What about this problem makes it, the word about. It's not exactly 68%. It's about 68%. Now, you could also say something like, according to the normal model, you might see solutions saying this, according to the normal model, and what we are saying is that, yo, it's not exactly 68%, okay? It's actually closer to 68.3%, actually. But even so, it's not exactly 68%, it's about 68%. And so we don't want to be definitive in our answer. Okay. Let's continue on. Let's do another one. Let's do a part B. Okay, so let's actually make this top one. Same question. This is A, 405, 600 points. And B, what percentage score higher than 600 points? Okay, now we're getting a little bit trickier. Okay, now we can get this answer we know we can get this answer off the top of our head. 600 is 1 standard deviation above the mean. All right, I know 68% is in between 1 standard deviations, which leaves 32% left over, which means 16% would be above 600. I can do it. It's doable using the empirical rule. But you don't want to do that. You can do it, and if you really have a good sense of it, it gives you an idea. And here's why that's important. On the SAT, a lot of you are going to run out of time, including there's multiple choice. So if you know what your answer should be about, oh, my answer should be around 16%. Ooh, look at that answer right there. It says 15.9%. Boom, bubble in, go on. Saved a lot of time. Oh, my answer is actually 1.2 standard deviations. Well, above 1.2 standard deviation. Well, I know 1 standard deviation is 16%, so my answer should be less than 16%, but somewhat close to that. Ooh, look, there's a 14% as one of the options. Boom, circle that, move on to the problem. These are very important. That's why the empirical rule can be very helpful, because it gives us a good baseline of what our answer should be around. Should it be more than, less than, greater than certain percentages? Very helpful. All right, what do I do to solve this problem? What do I do? What do I do for my solution? What do I do for the solution to get full credit on the AP exam? Sketch. Ooh, good sketch. So, find the z-score. 600 minus 500. Oh, I guess I was going to say the next thing is find a z-score. It just becomes automatic. 100 equals 1. All right. Now, where do I sketch? Oh yeah, Nani was the one who said, she had said sketch. That's why I went over. But she was a little shy and didn't say out loud. But I went forward with her answer like she talked about to everybody. She was correct. Where do I sketch? Where do I shade? Sorry, where do I shade?
To the right of 600.
To the right of 600. And so now we need to find this area. So how do I find that area? Well, if I use the empirical rule, I know that that area is about, using the empirical rule, I know that that area is about 16%. Okay? That's kind of like you had some questions maybe that, I think I had a question like that on your homework last night. So it's about 16%, right? Because it lands exactly 1 standard deviation. But that's not going to help you in tomorrow's homework, okay? So we need to know how to use the graphing calculator. So I need to use what? What am I going to use to find this?
The distribution pattern.
Yeah, so I'm going to use that normal distribution. Normal distribution. Which can look different depending on the calculator you're using. So very tough part. I can't see, making sure I can't go over everybody's shoulder and making sure every single one of you has the calculator out. And well, you know, the nice thing about when we're in school is that everybody's using the same technology. You're all using a handheld graphing calculator to do it. Now all the instructions apply to all of you the same. Some of you are going to use, you have that calculator. Some of you have an updated calculator. Some of you have the stats wizards on, so you can just put in the numbers. Some of you are going to use Desmos. Some of you are going to use the other ones. Desmos, I think, can actually be something very, very helpful on doing this one, to tell you the truth. This one can be a little bit helpful. Because the problem here with this graph is, what is my lower bound? What is my lower bound in this problem?
600.
600. What is my upper bound? And this is where it gets complicated. In this picture, what is my upper bound? Where do I stop shading on my upper part?
Don't you just shade the rest of the graph?
There is no upper bound. It goes on forever. So there's two ways. If you understand the concept of infinity, you can actually put in infinity right in here when using Desmos. So on Desmos, it's the default is infinity. So you can just leave it as that. All right. Our other calculators require us to put something in.
That in the AP exam?
Well,
You can do that in the AP exam?
remember, you don't get any credit for how to calculate it. You don't get any credit for typing normal CDF or anything like that. You just have to find the area. So it doesn't matter if I guess I should have changed the colors, because what you need, what is required, is this, and then the answer, right? So we need that answer, and then we need, of course, the context piece. So those are the two things that we need. We need all that stuff with the sketch, the z-score, the shading, and then we need the answer and context. All right. Everything else is kind of like behind the scenes. So what we do, when we often do, is we just write a really, really big number. So you can just write 9999999, you know, as many nines as you want. It's just a really big number. You might often see the calculator say 1E99, which is 1 followed by 99 zeros. So it's a really, 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 really big number. All right, you just put in a big number. It depends on the feature that you're using for them. Okay, so let's do it.
Okay.
Let's use the traditional calculator first. Let me take off this mode. I can't do it. All right, so second distribution, normal CDF. My lower bound on this picture is 600, and my upper bound goes on and on and on and on. So I'm just going to say a really big number like that, okay? That's infinity for us. And my mean is 500, and my standard deviation is 100. Now, and then I hit enter. I paste it, and this is how it looks in when I type it in. If you're using a regular calculator that uses, when you have to type it in, it'll look 600, 999, comma 500, comma 100. And I get 15.9%, which is about 16%. Both answers would be okay. If you wrote about 16%, full credit. About 15.9%, full credit. Okay. Let's use Desmos. Okay, so calculator on Desmos. I'm going to go to functions, distributions, and the normal distributions. My mean is 500, comma, standard deviation is 100. I'm going to use the cumulative. Hit that little check button. And look, it actually has the infinity buttons there. So all I have is a minimum. All my problem does is has a minimum. So my minimum is 600, and I don't have to change anything. It automatically uses infinity for the upper limit. It's nice. It's pretty cool. It's pretty accessible to me. It's the first time I've seen the Desmos one, actually, to tell you the truth. And because it utilizes it's able to utilize the concept of infinity, and it puts those in as its defaults, it's actually pretty useful. I don't care how. I don't care if you use the calculator. I don't care if you're using the graphing calculator app or if you're using Desmos. You need to give me that answer as a sketch. And then the answer is 0.159. So my final answer is about 15.9% of students score above 600 points on the math SAT. Those two things that are boxed, those two pieces that are boxed, are both part of the answer. Now, of course, if it's multiple choice, you don't have to make the sketch. All you have to do is get to that 0.159. You might see 0.159 or 15.9%. You might see 16% as your option choice. They all work the same. All right, and it is 10:48. We can sketch between. We can also do the same thing with below, and below would just be negative infinity. So let me put that. If it was a sketch that looks like this.
5 minutes.
Hold on real quick before you leave. I know my answer will be greater than what? My area will be greater than what in this picture? What is my answer going to be more than? I know my answer.
Oh, 5.
My
It's
answer.
going to be greater than 5.
No, it's a percentage. Areas below 1. I know my answer will be more than 0.5. It'll be greater than 50% shading. All right, I'm saying for just any random problem here. All right, but if I wanted to do this, it would be like normal CDF, and then it would be negative 9999, and then the commas. Like that. So because it goes on and on and on, this is technically like negative infinity over here and positive infinity over here. So my minimum would be negative infinity or negative 9999999, and just a really big negative number to get that one. You might see someone's below as well. So sometimes the questions are below, sometimes the questions are above, and actually it turns out the easiest ones when using the graphing calculator are the ones between. Thank you, everybody. Homework is posted. See you tomorrow.